This video continues on part 1, where we learned Ohm's law. Part 1, we learned Ohm's law. You'll remember that your electrotechnics N4 chapter 1 is based on current flow in an electric circuit. So current flow in an electric circuit is then separated into these 4 subheadings, if I'm using the correct words. You learn Ohm's law, you then learn resistivity, temperature coefficient, Kirchhoff's laws, and Norton's law. Even if your book doesn't have this law, you need to know it so that when you calculate, when you are asked to calculate using it, or it will make things easy for you to calculate something, then you will use this law. But on the last video we were here, so now we'll be here on resistivity. So the resistivity will be calculated in most cases using this formula. So whenever we are asked to calculate the resistance, R will be the unknown. So now whenever we're asked to calculate resistivity, that's what we'll be calculating. So we will make this the subject of the formula. If we are asked to calculate R, will be given this and this, the resistivity, the length, and the area. Sometimes we won't be given the area, they will give us the diameter. So we will just use the formula for an area to calculate we'll use the diameter in the formula of an area to calculate the area. Then we come and calculate the resistance if we are asked to calculate the resistance. So you know that is the resistance, you know that is resistivity, that is length, and that is area. So now that we know what is being represented by this formula, let's do exercise 1.3 so that we can get to know how are we going to be asked to calculate either the resistance, the resistivity, the length, and the area. Why I'm using this book is the best book. Not specific this book, any book will be the best to teach you current flow in an electric circuit, because a book will separate these subheadings and teach you one by one and give you exercises on them one by one. If you go to a question paper, they will either ask this, or this, sometimes 2 of them. So a question paper doesn't start teaching you like a book teaches you. So we've learned Ohm's law, let's now do resistivity. So this is the exercise that we'll be doing. Remember, on part 1 we did this one. We're still gonna do the question papers, should you be concerned about that. But you know I am always on the field, so on my spare time I make these videos. I will keep making these videos, but on my pace. So enough about talking, let's do the calculation. So this is number 1. They said we must calculate the resistance. Okay, what we are asked to calculate is R of 1000 meters of copper. 1000 meters is our length. We know length is given in meters and area will be given in meters squared. So should we be given in something like this in millimeters squared, we need to convert it. So we've got our length, which is 1000. What else we need? Which has a cross-sectional area. Okay, that is area, that is A. If the resistivity of copper, that is the resistivity. So let's write down what we have. This is what we have here. length is 10 meter, and we are told that the area, okay, let's start by the resistivity, because the area we will need to convert it. It's 117,3 times 10 minus 3 microohm meters. So microohm meters, okay. Also here we don't need this micro, so micro is minus 10. So what happens, if you remember maths, when we have 10, when we have two same bases, when we are multiplying two same bases, what happens? What happens is that these will add. So this is minus 3 plus minus 6, which is minus 9. So this is the same as 17, 3 times 10 minus 9 ohm meters. Our area is given as 35 millimeter squared. So we need to convert this in meters. So this is what happens when we convert this in meters. To convert it in meters, we divide by 1,000. So this is gonna be 1,000 is the same as 10 raised to 3. So this is gonna be 35 times 10 raised to minus 3. So remember this formula, what we are doing here, we are converting millimeters, not millimeter squared when we say minus this. So if we want to convert this to millimeter squared, that means we need to square this. So what happens when we square these exponents? They will multiply, and what we will have here is 35 times 10 minus 6. That's what we will have here. So we are now in meter squared. So now we can calculate R, because we have area, we have resistivity, and we have the length. So we said R is equal to resistivity times length, all divided by A, which will be calculated by substituting everything. So let's substitute 17,3 times 10 raised to minus 9 times the length, which is 1,000, all divided by, tell me what's A, it's 35 times 10 minus 6. So maths tells us this one will go on top and become positive 10 raised to 6, and since these are the same bases, we will be left here with 10 raised to minus 3. But the calculator makes things easy for us, because we can just punch this in the calculator and then get the answer. So let's punch it. This is 17,3 times 10 raised to minus 9 times 1,000 divided by 35 times 10 raised to minus 6. This gives us 0.494. So let's write that down. 0.494 ohms. So what did they get here? They got 0.495, but here we got 0.494. Then we are right. Let's come to this one. This one was very basic. Let's use the different color now for this one. This statement tells us the resistance of the heating element made up of nickel chrome wire is 20 ohms. So we are given the R now resistance, and it's of NC, nickel chrome. If you want to, you can represent that even that one was, that R was for copper, that resistance. So they are saying is 20 ohms. So now once we are given R, we know that we're not calculating R on this exercise. The wire is a cross-sectional area. Okay, they do the same thing again. They give us the area in millimeter squared. So 0.43. What is gonna happen? We're just gonna put that times 10 minus 6 meter squared. What else are we given? They must give us the resistivity if they don't want us to calculate it, and the resistivity of, so we are given the resistivity, that is 1,2 microohms. So we're gonna take out micro by saying times 10 raised to minus 6 like we did there. Then we have ohm meters. So you are not given length, then you know you'll calculate length. Calculate L. We must calculate the length of the wire used. So what is the formula? This is the formula. So if we are calculating length, we make L the subject of the formula. Okay, let's write R is equal to resistivity times L. So you know maths, right? This will multiply here and 1 will multiply there. We will then divide both sides by the resistivity, because that's what we want to remove. So this becomes R over resistivity. We said A multiplies there, so we'll have A here, and 1 comes there, so we just don't write 1. L is equal to this. So we can now substitute L on this formula. R is 20, the area is 0.43 times 10 minus 6, all divided by resistivity, right? Which is 1.2 times 10 raised to minus 6. So our length will be in meters, because we substituted there. I mean, we converted millimeter squared to meters. Because now we have resistivity underneath, this M will cancel 1 M there. And because we have ohms underneath, ohms will cancel these ohms. So that's how you get units here. Now let's punch this on my calculator. We'll just punch it as it is. 20 times 0.43 times 10 to an exponent of minus 6. then divided by 1,2 times 10 to an exponent of -6. So this cancel, -6. Let's see what the calculator will give us. The calculator gives us length as 7,167. We said we are in meters. What they got here they got 0,71. I've got a call that I must attend. Let me pause. Sorry about that. I must take these calls because as an appliance technician I get calls that book me for call outs. So we said this is what we got here and this is what they got here. What did we do wrong? Okay, this is what I did wrong. This resistivity is given as 0,0. So that was my mistake. There is 0 there. So that means there is 0 here. So this is an exercise, right? So you need to practice and avoid these mistakes that I'm doing. But at least I'm not hiding my mistakes. The reason for that is that I really don't have time. So if I have to stop this video and redo this video, it's gonna be a problem because that's gonna take my time, which I don't have much. So that is L, and this L corresponds with what they have there. Now let us come to this one. We need something that will make us think, yeah, now we've been doing easy things. What are we asked to calculate here in A? They asked us to calculate the resistance of the wire and the power dissipated in the wire. Before even reading, we are given the resistivity and we don't have to convert it. It's in ohm meter. Then we are given the length. This one is interesting. Let's do this one. Yes, we have current that we are given. So on this one, let's collect what we have. Let's use a different color. What we have here. Okay, let's read the statement. A current of, that is I, equal to 2 amperes, passed through the length of resistance wire 20 meters. We are given L, 20 meters, no conversion needed. The length of resistance wire 20 meters in length, and they tell us that 2 millimeters squared in cross-sectional area. So we know that that area from what we learned there is going to be written as 2 times 10 raised to -6 millimeters squared. And now we are given the resistivity. The resistivity will be calculated by, is equal to 420 times 10 minus 9 ohmmeters. So they say we must calculate R, then calculating R is easy. Then after that we calculate power. Then we will need to use that formula we learned on Ohm's law. Okay, let's just substitute on the formula to get R. That is our formula. The resistivity is 420 times 10 minus 9 times length. Length is 20 all divided by the area, which is given as 2 times 10 minus 6. So let's punch this in a calculator. Calculators, they makes us not good in maths, but even if you were good in math with this one, minus 9 times 20 times 20 all divided by 2 times 10 raised to minus 6. This is equal to 4,2. This is what they got also there, 4,2 ohms. So for us to calculate power, we know the current and the resistance. So that means we need the formula that has I and R to calculate power. So a formula that has I and R is the one that says I squared times R. So I squared will be 2 squared, because we are told that the current is equal to 2, and R will be 4,2. What power we will get here? We have 2 squared times 4,2, and this is equal to 16,8 watts. Power is calculated in watts, so that's what they got there. Now we are done with this one. Let's come to number 4. Number 4, I was once a student, so my lecturer told us to put 0 there. He said this is 10,000 for us to get this, but in the question paper you don't know the memo, remember, so you were gonna use what is given. So let's just respect this old guy that taught me this, and I did that there. Let me fold this paper like this so that we will use this part. Is this challenging? A coil has turns. This is challenging. So we have turns. What do we use to represent turns? Let's just use N. I think on transformers we will be using N to represent the number of turns. If I'm wrong, I'm wrong. We will see by then. We are told that a coil is 10,000 turns of insulated copper wire. The average length per turn is 150 millimeters. So we have length, which is 150 millimeters. So now we want to convert this to meters per N, because we said we will represent N turns by N. And what else we are told? The area. The area is given as 0,3, okay, 0,3 millimeters squared. So we convert this. We know that to convert this, we multiply it by 10 minus 6. Then we are in meters squared. We are in meters squared. We need to go there and fix that problem, because what are we asked to calculate? You calculate the resistance of the coil. Okay, let us first write the resistivity, which is 0,02 micro, which is times 10 minus 6 ohms meters. So we will be calculating R here. This is the unknown, and it will be calculated by this formula. Our problem is with L per 10 turns. in millimeters. I have another coil. I have a lot of work tomorrow, eh? Calls keep coming. Let us continue where we were. I'm sorry about that, guys. You can't complain about me getting callouts. As the channel tells you, I am an appliance technician, so I go out to fix people's appliances. So they must call me and arrange with me. We said we've got this formula to calculate the resistance, and we're given this, we're given this. Oh, the problem was here. See, I forgot now what was the problem. The problem was here. How do we convert this when it's per tens, and when we have 1,000 tens, and when this is in millimeters, we know we will convert it by dividing by 1,000, which is 10 raised to 3. But what we don't know is what we must do with these tens. That's what we don't know, and we will know. So what we must do here is we need to consider these tens. So these tens, for us to get rid of per 10, if we've got 1,000 tens, that means this is what we should do. This is like this: 150 millimeters divided by tens. So how do you get rid of tens? You need to multiply with 10,000 n. So 10,000 goes with n. So how do we get rid of that? We said we need to divide by 1,000, which is 10 raised to 3. So that would be gone, and we would have meters now. So this is 10 raised to 3. Okay. 10 raised to 3, we said it's 1,000. Let's just write 1,000, right? And don't make our life difficult. Yeah, it's 1,000. So this cancel that cancel here, this cancels here. So on top we are left with 10 times 150. So let's say 150 times 10. Let's see what is this equal to. This would be equal to 1,500 meters. So we solved the problem there. I hope you understand this. Now we can substitute on that formula to calculate R. That was the only thing that was challenging here, right? Is to convert that. So P, we are given, resistivity, we are given it as like this, minus 6 times L, which we found out to be 1,500, all divided by area. Our area we said is 0.3 times 10 raised to minus 6. So let's just punch this in a calculator. Calculators make our lives easy. 0.02 times 10 raised to minus 6 times, no, how did we came there, times 1,500 divided by 0.0, no, 0.3 times 10 raised to minus 6. This is equal to, so R is 100 ohms. Is that what they got here? That's what they got here. So I think this was gonna affect us if like we didn't say 1,000 there, 10,000, sorry. This was gonna be R equal to 10 ohms, I think, because yeah, I think so. I think so. But you can double check if you use 1,000 instead of 10,000. I'm sure you're not gonna get this answer. You're gonna get something different. But I'm not sure about this. I'm just thinking that's what we might get. So don't get me wrong if you don't get 10 ohms and say no, but he said we must get 10 ohms. But let's just punch it in the calculator. Let's just convert here using, so we were gonna be left with 1 here because these zeros were gonna cancel, and we were gonna have 150 right there instead of 1,500. So the calculator forgets everything. It's calculators. So let's put here 0,002 times 10 to the exponent minus 6 times not 1,500, 150. Ooh, we have a problem there. Times 150, all divided by 0,3 times 10 raised to minus 6 equal to 10 ohms. So I was right. Let's continue. Let us now do number 5. Number 5 is challenging. You can see that I put the stars. It's been long. I don't know when I forgot, but my statement will tell when I did electrotechnics N4. Well, enough about me. Let's use the different color. Let's take the information that is given to number 5 and calculate number 5. As we calculate, we'll see what was scary about number 5. A copper rod of 6 millimeter diameter. So we are given the diameter, and it's the diameter of copper is 6 millimeter. This is the same as saying 6 times 10 minus 3 meters. That's what we want, right? We want to use meters. And 1 meter long. So it's still the copper rod. So this length is for copper and is 1 meter. We're not converting, and has a resistance of 670 micro ohms. So this resistance is still for copper. It's said to be 670 micro, so we'll say 10 instead of micro times minus 6 ohms. So on the copper, note we are not given the area, so we need to calculate the area of copper because we don't use diameters here, we're using area. Okay, we'll come back there. The statement continues, if the rod is drawn out to a wire, okay, rod is drawn out to a wire which has a uniform cross-sectional area. Now we are being given another area, and this one is for a wire. It is said to be 0,08. So I would say 0,08 times 10 to put this in meter squared minus 6, then that's meter squared. Calculate its new resistance assuming the temperature to remain unaltered. So we want the R wire here. So do we know L for a wire? We don't know. Okay, I don't know whether your formula should have this formula, but for us to calculate R wire, we'll have to use a formula which says R2 A2 is divided by L2, which is equal to R1 A1 divided by L1. So this is the same as R copper A copper divided by L copper is equal to R wire, A wire, and L wire. So with one R wire, we make R wire the subject of the formula. This one comes here, and this one comes underneath. So R wire will be calculated by R copper, L wire, which we don't know, and A wire, all divided by LC. We said copper, copper, L for copper, multiplied by A wire. Okay, we know this, and this A wire is given. A wire is given. What happened here? I was supposed to say copper, A copper, sorry. I'm confused now because I see A2 A wire. We know this. A copper, because A copper would be calculated in that using that diameter. A wire is given. L copper is given. We need to go and look for this guy. After getting this guy, we will then be able to calculate R wire. So in the statement, they say the temperature is unaltered. So what we know that if the temperature is not altered, then since temperature will have effects on volume, so that means the volume on the copper and on the wire is the same. So this means if we can calculate the volume for copper, we would be able to use that volume somewhere. Isn't volume is equal to area times L. So if we calculate the volume for copper using area of copper and the length of copper, we can then use this volume to calculate, because this volume is the same as the volume for wire, which will be calculated by A wire and L wire. So we know A of a wire. Once we get this volume, we say these are equal. So we use this volume here to calculate L wire. Therefore, L wire will be calculated by volume of wire divided by A wire. Once we get this length of the wire, we can come substitute here, and then we will get the resistance of the wire. So let us now apply it. We said we need to calculate the area for copper. Okay, what we will do here, we will just substitute there. We know that the area is pi d squared. This d is for copper, divided by 4 multiplied by L for copper. So the volume for copper is gonna be pi diameter 6 times 10 minus 3 squared, all divided by 4 times the length of the copper is said to be 1 meter. So the volume for copper is, let's ask the calculator to help us, pi times 6 times 10 raised to minus 3. Then we close the brackets, we square d, which is the diameter. 1 changes nothing. So if you like it, you punch 1 and then we divide by 4. This is the same as 2,827 times 10 raised to minus 5. A volume is in meter cubed. So now we said we will use this volume, remember, to calculate length of a wire. So length of a wire is gonna be volume of a wire, which is the same as the volume of copper, 827 times 10 minus 5. Forgive me, I have my space is not enough. All divided by cross-sectional area of a wire, which is said to be 0,08 times 10 raised to minus 6. So let's just divide the answer there with 0,08, and this is 0,08 is multiplied by 10 raised to minus 6. This is equal to, this is now the length of the wire. It's said to be 3,534 times 10 raised to negative 10, as we can see, and this is in meters. So now can we then calculate, because what we're using here, we're dividing meter cubed by meter squared, so we are in meters. So now we can substitute there, because we know this guy now, and the answer that we got here, we multiplied by 1. So this is the same as the area of copper. I hope you agree with me, because this was equal to 1. So we were just calculating the area of copper, but since we had meter there, 1 meter, so that meter squared here we got was multiplied with that meter, then it was meter cubed. So if we say this is the area of copper, we can write the area of copper as 2,827 times 10 minus 5 meter squared. So let's substitute to get the resistance of the wire. RC, R copper, where is R copper? Is here, 67 times 10 minus 6. And what else we must substitute? It's L wire. Where was L wire? Is here. And it's times 3, 5, or 3,5, 3, 4 times 10 raised to minus 10. We also have one more thing to multiply here. According to this formula, it's A copper. The area of copper, we said, is the same as this, right? So it's gonna be 2,827 times 10 minus 5. All of this will be divided by L copper and A wire. What is the length of copper? Is 1. And what is the area of the wire? We calculated the area of the wire, or we were given it. We were just given it as 0,08 times 10 minus 6. So if we punch this on a calculator, we should get this. If we're not getting this, I don't know, and I can't tell. 670 times 10 raised to minus 6. This minus 6 must cancel this minus 6, but the calculator knows that. Then 3,534 times 10 raised to minus 10 times 2,827 times 10 raised to minus 5. All of this is divided by 1 times 0,08 times 10 raised to minus 6. And our answer is, I record here, this is our answer, 8,367 ohms, or times 10 raised to minus 11. So how is this possible? We have a lot, then this cancels that, we have that. So, well, that's what I'm getting here. If you calculate this and then you get exactly this, you have something to teach me. I think here it's not ohms. Maybe it was supposed to be mega or micro, yes, something like that, then ohms. So this is what I got. Now let us continue and calculate. Let's fold this. Let us come to number 6. On number 6, number 6 is basic, right? It's the same as, where have we calculated tens? It's the same as that one because we have tens again. So let's calculate number 6, and don't be afraid of number 6. Number 6 will be calculated when we have taken the information we are given. Tens, a coil is made up of 2000 tens. N is equal to 2000 of copper wire, which has a cross-sectional area of Then we are given the cross-sectional area of copper, which is 0.8 meters squared. So we said this is the same as 0.8 times 10 minus 6, 10 raised to minus 6 meters squared. The mean length pattern, then we are given the length in centimeters now, not in millimeters. It's 80 centimeters. So we need to convert centimeters to meters. So we just divide by 100, not 1000, because this is not millimeters. So 80 divided by 100 is equal to 0.8. This is 0.8 meters length, but now per 10. If we want to get rid of per 10, what did we do last? Okay, let's just rewrite that because I keep folding these papers. So this is the same as 0.8 meters divided by n. So if we want to get rid of n, we multiply it by 2000 n. So n and n cancel. So this is gonna be 0.8 times 2000. It's 1600 meters. Now we know L, we know A, what we don't know. Okay, let's continue. Calculate the resistance, assuming the temperature remains unaltered. So they tell us to calculate R copper. Temperature remains unaltered. So what is it that we are not given here? Oh, sorry, I read the statement there. I was shocked now. Ooh. We got this. What did I do? We are given the area, it's there. We are given, I think I'm tired, but I'm going to finish this exercise no matter what. Then the length per 10 is centimeter, and the resistivity of copper is, yeah. I was shocked because they ask us to calculate the resistance, but they don't give us the resistivity. What is the resistivity? 0.2 microohms. So this becomes 0.2 times 10 raised to minus 6 ohm meters. So can we calculate R here? Calculate the resistance of the coil and the power dissipated when the coil is connected across. So we given voltage. So here we can calculate R. I'm sorry, we've been doing this for long now. I think you understand it. I will just write the formula, we punch everything in the calculator, then we get the answer. Or let me just do this. The resistivity 0.2 times 10. These videos are becoming long, and it's not easy to upload them on YouTube. They're costing me time, data, and everything. But well, there is more happiness in giving than receiving. So I'm giving you this education for free. And if it helps someone out there, I am more happy than that person who is being helped by this video. Yeah, hey, that's the good way of looking at things, eh? Now we need to punch this in the calculator and get this resistance. If we don't get this resistance now, remember we got something different there, but which seem common. I'm gonna cry. We don't know who is right between me and these people. So I would like to hear on your comments what you got and what mistake I have done so that I can redo this. Raised to minus 6. Then we multiply this. We multiply this by 1600. Then we divide this by 0.8 times 10 raised to minus 6. Just cancel this and this and make your things shorter. Is 400 ohms. What is it that these people, what is it? Really, what is it that I'm not doing right? Because they said 40 here and the calculator is getting 400. 2000, 2000. And 0.8. Where is this 0.8? That was, yes, 0.8. And here, then we're given length as 8. We multiplied by 2000, then we got that. No, these people are wrong, because even if we would cancel there and there, we would then have 0.2 times 1600 equal to 320 divided by 0.8. Once you divide by a decimal, then the number is gonna go up. So please try to find out again if there's something that I'm missing. That is the biggest problem with books when they give us answers. So if they made a mistake, they don't come out, they don't rectify the mistakes. So power here will be calculated by V squared divided by R, because we are given the voltage. So the voltage is 110 all divided by, oh, this is squared, sorry, divided by 400. We're not going to use this 40. We will see if we get this, and when we used 400, then we know that they made a mistake here. 110 squared divided by 400. Yeah, these people, they wrong. I'm not sure, but try to see if you will get these values that they are getting. Me, I'm not getting them. But I'm in track, because this is, the difference is small here. So maybe we're supposed to put 0 there again, I think, to make this 1000. Maybe we're supposed to take out 0. I don't know, and I can't tell. Let us now come here. Let's just do this one here. There's NB there. Now I'm worried. Why was that NB there? An aluminium wire. Aluminium wire. me check my time. I work with time. Aluminium wire long is connected in parallel with a copper wire that is okay. It would be better if we have a drawing here, because now this is a connection that is said to be in parallel. So they are telling us that let me draw using this black pen. Aluminium wire that is 7 meter long is connected in parallel with a copper wire that is 6 meter long. So we have this. This is what is meant by parallel. So they are saying this is aluminium wire and it's 7.5 meters, and they are saying is connected to a 6 meter long. So we'll use pink for copper. So this is copper and this is aluminium. AL. Now, what else they are telling us? When a current of 5 amps is passed through the combination, okay, then 5 amps passed through the combination. So this is the total current, because they didn't say true aluminium wire so that we would know. And it is found that the current through the aluminium wire is 3. Now they are telling us the current here in the aluminium wire 3A. Ooh, I said I will use this one, but now I'm using that one. Hey, don't be like me. So this tells us that the current across the copper is 5 minus 3, 2. Kirchhoff's law. And what else they are telling us? The diameter of the aluminium wire is 1. So D, they are telling us D here, D. Well, Lily, you can't be me, because you say things and you don't do. Where we diameter is 1 millimeter. 1 millimeter. We know that we must convert this to meters. So this would be the same as 1 times 10, because we divide by 1000, minus 3 meters. Okay. The diameter, determine the diameter of copper. Ooh, my God. They want us to calculate the diameter of copper. The resistivity of copper. So they're giving us, hey, I say, really, you can't be me. You can't be me, because, so the resistivity, let's check the resistivity. Copper resistivity is 0.017 micro times 10 minus 6 ohms. And they said for aluminium, the resistivity is 0.028 micro, which is 10 minus 6, 10 raised to minus 6 ohms. Yo, how can we get this diameter really? Okay, we can calculate the area of aluminium, right? By PD squared all divided by 4. But where will it help us? Once we know the area of aluminium, what can we then calculate? maybe it will help us to calculate the resistance. Yes, it will definitely help us to calculate the resistance of aluminium, which will be calculated by resistivity of aluminium times the length of the aluminium divided by the area of the aluminium. So once we know the resistance of the aluminium, if we know the resistance and we know the current, we can get the voltage across the aluminium. The voltage across the aluminium is the same as the voltage across the copper, because these are connected in parallel. So once we know the voltage across copper, we can use the current to calculate the resistance across copper. We use Ohm's law to calculate the resistance across copper. Once we know the resistance across copper, from this formula we can calculate the area of aluminium of copper, because we know the length of copper, we know the resistivity of copper, and we will be knowing the resistance for aluminium. Once we got this area, we can then calculate the diameter through the formula of area. This was scary. Let's calculate the area of aluminium. They said resistivity is 0.28 times 10 minus 6 times the length of the aluminium, 7.5, all divided by area of aluminium. Okay, let's just substitute here to get the area of aluminium. We're given the diameter. We said the diameter is the same as 1 times 10 minus 3 squared, all divided by 4. So the area for aluminium would be, let's let the calculator tells us that, pi times, that is the same as 10 raised to minus 3, sorry, we close the bracket, we square that, we divide by 4, then what we get 7.854 times 10 minus 7 meters squared. So that is the area of aluminium. So we're gonna substitute this here. Let's substitute it. It's 7.854 times 10 raised to minus 7. So what I'll just do, I will just store this at A. So now I will punch this on the calculator. 0.028 times 10 raised to minus 6 times 7.5 divided by, there's a big mistake there, times 7.5, all divided by this. Let's recall that what we saved to A, then the resistance for aluminium is set to be 0.267 ohms. So this resistance can now be used to calculate the voltage across the aluminium. The voltage across the aluminium is equal to the voltage across copper because that's a parallel circuit. So that is why this book starts educating us Ohm's law, because we will need Ohm's law here. V is the product of current across the aluminium and the resistance across the aluminium. So we substitute here, and we know that the current is 3 and that the resistance across the aluminium is 0.267. I was supposed to use the different color there. So let's times here by 3 is 0.802 volts. So we said we're gonna say V across aluminium is equal to V across copper. Therefore, V across copper is equal to 0.802 volts. So to calculate the resistance across copper, we will say voltage across copper divided by current across copper. I think you will have to write this down here. Maybe there are marks for that. Don't just do it as I did there. Voltage across copper is 0.802 divided by, let's write that, 5 for us to get marks. 5 minus 3, which is 2. So let's punch this in the calculator. 0.802 divided by 2 is equal to, so the resistance across copper, I just want to write it here, is 0.401 ohms. So once we get this resistance across copper, we said on the formula saying, let's use a different color. No. Why am I writing voltage? Copper is equal to resistivity of copper times length of copper, which is known, divided by, okay, let's say all divided. Let's divide like this so that it can be seen. So area of copper. So this one comes here and this one comes down. So area of copper will be calculated by resistivity of copper times by the length of copper, all divided by the resistance of copper. So A of copper is, let's substitute resistivity of copper 0.017 times 10. Let's hope we will get this one as it is written in the book. But even if we don't get it, it's not the problem. We know the strategy. The length of copper is 6 meters. Let's divide by our copper, which is 0.401. Let's punch this in the calculator. 0.017 times 10 raised to minus 6 times 6 divided by 0.401 is equal to 2.544 times 10 raised to minus 7. This is the area in meters squared. Now, on that formula, let's make D the subject of the formula. So we say A copper now is equal to D copper squared all divided by 4. This makes us have D squared equal to 4A copper, because this comes and multiply here, divided by R. So we divide by R. We divide by R. I'm disturbed by this call. Where was I? We divide by pi, sorry. So we put the roots on both sides to get rid of D squared. Therefore, the diameter becomes 4A copper pi. So let's substitute here. We have 4, and the cross-sectional area we said is times 2,544 times 10 minus 7, all divided by pi, and all of this is in a root. So what I'll do here, I will again store this answer to B. I will just recall B for this. So let's say 4 times, recall B, times, oh sorry, not times, delete that. Let's divide. Oh, the calculator doesn't want to do this the way I want it to do it. Let's say 4 times, recall B, all divided by pi. That was going to be the same thing, I'm sure. This is equal to this. So let's store this. I like to store it to C. So let's take the root and then we recall C. Then what do we get? The diameter is said to be 569. This 569, this 0 changes to 1. And this is multiplied by 10 raised to minus 4. And this is in meters. So can we change this to millimeters? Yes. We can multiply the answer. We can multiply the answer by 1,000. We will then get 0,569 millimeters. So that's what we get if we convert this into millimeters. And there it is. At least this one we got it. So please don't forget to subscribe to my channel, like this video, recommend this video to other students that you know that are doing electrotechnics N4. I am gonna complete this book. So what I'm doing here, I'm making a complete course for N4 Electrotechnics. Then depending on time later, I will then do exam preparation for N4 Electrotechnics using the previous question papers. There at least we won't have a problem of answers like we have in this book. Thank you. I hope you learned something.